On August 15, 1977, a radio telescope in Ohio detected something strange. A signal, 72 seconds long, coming from the direction of the constellation Sagittarius. It was 30 times louder than the background noise of space. The astronomer who found it circled the data on the printout and wrote a single word in the margin: "Wow." We never heard it again. We still don't know what it was. But for 72 seconds, something out there was loud enough for us to notice. That was almost 50 years ago. Since then, we've listened to thousands of stars. We've discovered over 5,000 planets orbiting other suns. And we've heard nothing else. The silence is deafening, and it demands an explanation. In 1961, astronomer Frank Drake wrote an equation, not to solve the problem, but to frame it. The Drake equation multiplies together all the factors needed for detectable civilizations: stars with planets, planets with life, life that becomes intelligent, intelligence that builds technology, and how long those civilizations survive. We've since learned some of those numbers. At least 20% of stars have Earth-sized planets in habitable zones. That's billions in our galaxy alone. Even with conservative estimates, even if life is rare, even if intelligence is a fluke, the numbers suggest millions of civilizations should exist. The universe is almost 14 billion years old. Earth is only 4.5 billion. If intelligent life arose elsewhere just 1% earlier than us, they'd have a 100-million-year head start. Enough time to colonize every star in the galaxy. Twice. So where is everyone? In the summer of 1950, physicist Enrico Fermi sat down to lunch with colleagues in Los Alamos. The conversation turned to UFO sightings, then to the probability of alien civilizations. Fermi thought for a moment, did some mental calculations, and asked a question that still haunts us. Where is everybody? This is the Fermi Paradox. Not a flaw in logic, but a collision between expectation and observation. The math says the universe should be crowded with life. Our telescopes say it's empty. Both seem true. Both cannot be true. One of our assumptions is wrong. But which one? Over the decades, scientists have proposed dozens of solutions. Some are hopeful, some are terrifying, and one of them might be true. The most unsettling answer: we are alone, not because life is impossible, but because intelligent life requires a chain of coincidences so improbable it might only happen once. Look at Earth. It's not just in the habitable zone. It has a massive moon that stabilizes its axis, preventing wild climate swings. It has a magnetic field that blocks lethal radiation. It has Jupiter acting as a cosmic bouncer, deflecting asteroids that would otherwise sterilize the surface every few million years. It has plate tectonics recycling carbon. It has liquid water for 4 billion years, uninterrupted. Remove any single factor and we might not be here. Life appeared on Earth almost immediately after conditions allowed. But complex life took 3 billion years longer. Intelligence took longer still. The jump from bacteria to brains might be so improbable that it only happened once, on this one world, around this one ordinary star. Perhaps the universe is vast and ancient and empty, except for us. There's a darker possibility. Economist Robin Hanson proposed what he called the Great Filter, some step in the journey from dead matter to star-faring civilization that is nearly impossible to pass. The good news, the filter might be behind us. Perhaps the origin of life is the miracle, or the leap to complex cells, or the development of intelligence. If so, we've already beaten the odds. We're the lucky ones. The bad news, the filter might be ahead. Perhaps every civilization that reaches our level of technology destroys itself. Nuclear weapons, engineered pandemics, artificial intelligence that slips its leash, climate systems pushed past the point of no return. If this is true, then the silence of the universe isn't empty. It's a graveyard. Millions of civilizations rose, reached for the stars, and fell. Each one thought they were special. Each one was wrong. And if this is true, our future is already written in their ruins. Perhaps the answer is simpler. The distances involved are beyond human intuition. The nearest star is 4 light-years away. Voyager 1, the fastest object humanity has ever built, has been traveling for over 46 years. It has covered less than 1/10 of 1% of that distance. At its current speed, it would take 70,000 years to reach the nearest star. And here's a number worth remembering. Humanity's radio signals have been spreading into space for about a century. That means our bubble of detectability is roughly 200 light-years in diameter. The Milky Way is 100,000 light-years across. We have announced our existence to approximately 0.0004% of our own galaxy. If there's a civilization on the other side, our signal won't reach them for 50,000 years. Their reply won't arrive for 50,000 more. Perhaps the galaxy is full of life, all of it shouting into the void, none of it close enough to hear each other. We've searched for radio signals for decades, but a civilization 1,000 years more advanced might have abandoned radio long ago. Searching for their broadcasts would be like the Roman Empire trying to detect our civilization by looking for smoke signals. Consider, we went from first radio transmission to fiber optic cables in less than a century. Our planet has actually gotten quieter in radio frequencies as we switch to more efficient technologies. A truly advanced civilization might communicate through methods we can't conceive. Quantum entanglement, gravitational waves, something we don't have words for yet. Perhaps the universe is full of messages. Perhaps we simply don't have the senses to perceive them. Two more possibilities, both unsettling in different ways. The first is almost comforting. The zoo hypothesis suggests that advanced civilizations have agreed to leave emerging species alone, like wildlife preserves on a cosmic scale. We're not being ignored, we're being protected or studied. The universe is full of life, but the grown-ups have agreed not to disturb the children until they're ready. The second possibility is not comforting at all. Science fiction author Liu Cixin called it the dark forest. Imagine the galaxy as a forest at night. Every civilization is a hunter, moving through the darkness, armed and afraid. Resources are finite, alien psychology is unknowable, and any civilization advanced enough to reach you is advanced enough to destroy you. In the dark forest, the winning strategy is silence, hide your existence. Never transmit, because any signal you send might be your last. And if you detect another civilization, you have two choices: destroy them before they grow strong enough to threaten you, or stay hidden and hope they never find you. Perhaps the universe is full of life, all of it silent, all of it afraid. Perhaps our radio signals, spreading outward for the past century, were a terrible mistake. But here's a possibility we rarely consider. What if we're not late to the party? What if we're early? The universe will exist for trillions of years. We arose when only a small fraction of all stars that will ever exist have formed. The universe is still young. We might be among the first minds to open our eyes and wonder. This would explain the silence. It's not evidence of extinction, it's not evidence of hiding, it's the quiet before the dawn. If this is true, then the question isn't, where is everybody? The question is, what will we become? We could be the ancestors, the first civilization to spread across the stars. 100 million years from now, some young species might look up at their sky and wonder about the ancient ones who came before them, the ones who left ruins on 1,000 worlds, the ones who seeded the galaxy with life. They would be wondering about us. The silence of the universe might not be a warning, it might be an invitation. The Fermi Paradox matters because every answer changes everything. If we're alone, then every war, every extinction, every failure of care is a crime against the only consciousness the universe has ever produced. We become infinitely precious. If the Great Filter is ahead, then our survival depends on solving problems no species has ever solved. We carry the fate of all intelligence in our hands. If the universe is full of hidden life, then first contact could come tomorrow and everything we thought we knew would change. And some peace, all go ours. And if the dark forest is real, we may have already made a fatal mistake simply by existing loudly enough to be noticed. Every answer is profound, every answer reshapes our destiny, and we don't know which one is true. Somewhere in the constellation Sagittarius, whatever sent the wow signal has been silent for nearly 50 years. We don't know what it was. We don't know if it's still there. We don't know if it ever noticed us at all. But we're still listening. We're still searching. And with every exoplanet discovered, every signal analyzed, every probe we send deeper into the darkness, we get closer to an answer. Maybe we're alone in a universe that doesn't care. Maybe we're surrounded by civilizations too far away or too different to reach. Maybe we're being watched by beings we can't comprehend. Maybe we're the first chapter of a story that will span billions of years. The Fermi Paradox isn't just a question about aliens, it's a mirror. It asks what we believe about life, about the universe, about ourselves. And how we answer reveals who we are. Somewhere out there, or nowhere at all, the truth is waiting. The question is whether we'll survive long enough to find it. Next time, we'll explore the most terrifying answer to the Fermi Paradox in depth. Is it behind us, or are we racing toward it? The answer might determine the fate of our species.